cloud technology for satellite constellation management, where we will discover how cloud technology supports the rapid growth of satellite constellations for EO, RS, and internet broadband. Keynote address, Mr. Lakshminarasimhan S., APJ Solutions Architecture, Aerospace and Satellite Solution, AWS. Now I would like to invite our panelist for today, Mr. Tanveer Ahmed, CTO, Digantara. Also, Mr. Rajeev Nair, Senior Vice President, APAC NeXat. Can we have a huge round of applause for all our panelists? I request everybody to please maintain the decorum of the hall, and you can have the discussions at the tea area. All right, then I request Mr. Pankaj Sharma to please lead the discussion. Thank you so much.
Good morning, ladies and gentlemen. My name is Pankaj Sharma. I'm partner with EY, and in this domain, within EY, I very specifically I focus on the satellite domain. So I would like to thank SIA for organizing this wonderful event over past 3 days, and to bring all the industry experts and policymakers together to discuss the topics pertaining to SATCOM industry. As we all know, I mean, satellite industry is making great strides in India, and the reason is one is obviously the focus from the government, the favorable policies that we have, and also as an industry, I think there are great innovations which are happening in this industry, which obviously we haven't seen before. I mean, what we have seen happening in past 4 or 5 years or so is something, which has really brought the focus as far as the satellite industry is concerned. And one of the topics that we're discussing today is harnessing the power of cloud computing for managing satellite constellations. So let me first invite Mr. Narasimhan, Lakshminarasimhan, to give the keynote address. Lakshmi.
Firstly, I'd like to thank the SIA for organizing this Space Congress and inviting AWS to be part of this. So today we are going to just look about how cloud computing can build solutions, help build solutions for managing large constellations. How do I move the slide? Sorry. Okay. Okay, so I can move to the next slide. So we'll quickly go through what is a problem statement that we are addressing today, because that's where we start as working backwards. So what is a problem statement? What are the challenges that typically traditional constellation or satellite operators face? And then what does it look? So, okay, yeah. So what does it look like from the space economy opening across the globe, and especially in India with such a huge opportunity area? So how does the new space age look like? Uh, and why AWS? Again, that's the first why we will start with. So we'll address 3 whys at the start, and then we'll address why AWS. Yeah. So starting from the launch of first satellites, so most of the satellites have been purpose-built, right, for specific use cases. So those satellites really met those mission objectives. At the same time, the use case or the customers want to expand their satellite assets. The number of satellite in the space increased, and with satellites being manufactured by different companies, different organizations, every satellite comes with its own dedicated mission operations or control system, having multiple TT&Cs, having different operating procedures for different satellites. And this impacted business outcomes. So the business outcomes can be for a commercial organization, can be different for a strategic user or for a commercial organization. So we are going to look at it from three different points of view. So first is from an operations point of view. With the number of satellites increasing, the only thing that was constantly happening for the satellite operators is change management, right? So with multiple systems, multiple technologies being used, change management becomes the permanent operational model. So, for example, if someone wants to change the uplink ERP for a specific transponder, then there'll be a different way they need to test the commands. They need to test the commands locally. It will be different formats for different satellite manufacturers. And this slows down the entire process for the satellite operators. And it impacts the business growth, right? Because if I'm not able to make changes quickly, that's an opportunity cost for the organization. Coming from a technology standpoint, we saw that the missions were built for specific proprietary use cases, which means as the number of satellites increased, as the number of use cases increased, the change management becomes difficult, right? So at the same time, the number of technologies changing and different applications. So every satellite operator comes with its own MNC, and these applications are built in a monolithic manner. And when you want to change even one aspect of that application, say either a digital signal like 0 or 1. So if I have an increase in database, then I need to change the entire application. So that's where that is one of the challenge. And with that, with many systems, data is in silos. Heterogeneous type of data sets needs to be processed. Many different data pipelines. And with all these, the computing power is still limited. Storage capacity is still limited. So what end customers are looking for is, what is the data insight that I need from these data? How can I get it faster? So again, slowing down these impacted business outcomes, which needs to be taken based on data. Being a data-driven organization is extremely important for us to scale, right? Third, from a business standpoint, for any business, the most important thing that they start from a risk management perspective is, how do I continue to have my business? How do I run my business continuity? What is my disaster recovery procedure? So to build a highly resilient solution, the satellite operators need to build multiple physical locations, right? So they need to have a primary mission operations center, then they need to have a secondary mission operations center and have these connected to each other. So which only increases the security aspect. So cyber security is now coming into picture here. So having 2 locations connected to each other, how do I do physical access control? How do I do infrastructure control? Who is going to maintain my locations? And network security, how is the data being encrypted between those 2 locations? Identity access control, and just the list goes on. So with all these challenges, how can the satellite operators still achieve security and speed to have their business outcomes met, and at the same time in a cost-effective manner? we can bring it forward. So till now we are looking at proprietary missions, right? So every customer is going to probably have a constellation. And today, as we speak, we have 9,000 plus active satellites in orbit. New missions, new orbits, new business models new satellites are being built to drive extraordinary different business outcomes. So with this number of satellites getting increased, what we're going to see is an exponential increase of data. And we are already seeing that it's going to be in multiples, tens or hundreds of exabytes of data that is only going to go. So we saw a different set of challenges from a traditional operator standpoint. And now we are seeing a different scale on how the satellites are, how the space environment is going to change. Can we do this manually, how it is being done in a traditional manner? So that's the why that we are going to address today. So we're going to learn how customers are building scalable satellite operations to support large constellations on cloud and mitigating these challenges. So where do we sit? So as I know I didn't do an introduction there because I was waiting for this slide. So I'm Lakshminarasimhan, so I'm a solutions architect with Aerospace and Satellite within AWS. So what is Aerospace and Satellite? So most of them, I'm sure you are aware of AWS, which is the cloud computing arm of Amazon. So Aerospace and Satellite is a team that has been set up with dedicated subject matter experts, both from space and cloud, to primarily enable the space customers to reimagine their space architectures and build secure and scalable solutions. So we have more than 10 plus years of experience from industry leaders such as Airbus, Astra, Black Sky, and many other customers. So most of us know Mission Operations Center is a facility that basically supports satellite mission containing all the elements required for driving nominal and contingency operations. So this is the baseline that we are going to set today. Next slide. So we'll see why customers choose AWS for space operations and management from three lenses: reliability, scalability, and cost efficiency. And what we'll also do is we'll map it out across the three challenge areas that we discussed, which is operations, business, and technology. So we'll map it against those three stacks. Next slide. So from a broad view, space mission operations has various tasks, all the way from mission planning, command and control, flight dynamics, payload processing, data processing. So how can we realize this complex space mission operations on AWS cloud in a more scalable, reliable, and cost-efficient manner? So the first why we are going to answer is why customers choose AWS. So organizations around the world are moving to cloud-based infrastructure, primarily to increase their IT asset reliability, speed. Agility has been one of the key asked by various customers, and at the same time continue to lower cost. So moving to the cloud, what enables is customers are able to focus on their business products built, which is generating core value for their business, and remove the undifferentiated heavy lifting. Whether you build your own servers or you run on cloud, you're going to use the same hardware infrastructure. But what it helps customers is to focus on building their application. And at the same time, customers want to trust their assets and IT infrastructure to a provider that has most advanced systems, whether it is in security, process, and controls in place. So with cloud computing, AWS manages and maintains the technology infrastructure, in a secure environment, and business accesses these missions via the internet or a dedicated connectivity to develop their applications. From a sustainability standpoint, AWS infrastructure is 3.6x more energy efficient than the median of surveyed US enterprise data centers. In short, if I want to say in one line, AWS Cloud is the most secure, extensive, and reliable global cloud infrastructure. So we talked about reliability, scalability, and cost efficiency, right? So first is we're going to, we see the mission operations to be a highly modular environment. We don't, like we just saw about monolithic applications. So we don't want to build a monolithic application. What we want to do is we want to make it as flexible as possible for customers. So in simple words, it's like Lego blocks. So customers who want to pick and choose, say some customers may have built their own flight dynamics module. Some customers may have built their own mission control software. Some may have, so depending on what they would like to do, they can just simply bring in their application to run. And with the, what you see below is how a region, what we call as region and availability zones. So AWS intentionally designs and builds each of these layers from an infrastructure point for high availability. So this enables customers to run their application across multiple regions and availability zones. So I know now the questions most of you may have, the question is, okay, what do you mean by region and what is a region? So next. So I think one slide is. Can you go back? Okay. So what do you see at the bottom? A region is a physical location. So in India, we have two regions. So one in Mumbai and one in Hyderabad. So a region has minimum of 3 availability zones. In short, we call it as AZs. So each of these regions are by itself isolated, and each of these AZs are a cluster of data centers. And all of these are interconnected through our own fiber infrastructure. So we talked about security and speed. So from a security standpoint, AWS Cloud has 143 security and compliance certifications, a secure by design approach. So what you see here is different broad security levels, all the way from identity and access management or detection and response for compliance. So these tools are enabled to provide customers to build their secure environment. And so the idea is how can we help customers to build security with speed and automation, reducing human error with the best practices across the organization. So we saw about reliability, how customers can build applications in a different availability zones to create high availability for applications. So compute is really the core standpoint. Right? So the amount of data that we are generating on a day-by-day basis, whether it is Earth observation or internet usage, the core has always been data. So with the amount of data increasing, customers are looking at how quickly I can do a high-performance compute to simulate weather applications, or a high-performance compute for simulating flight dynamics. So what we're doing here is to give choice of various compute options to customers. Not only, so today AWS has got around 750 types of compute instances from different manufacturers, all the way from Intel, NVIDIA. AWS Cloud is the only one having an EC2 on Mac as well. So with the choice of compute, customers can build their own applications for serving different customer use cases. And so we are also the first EC2 instances which can support up to 800 Gbps of networking speeds. So GPU workstation. So with the, I'm sure you would have recently heard about the noise on Gen AI and so many customers asking, okay, how can I use, what can I use in there? So again, the question comes back to, does the customers have the ability or to buy the GPU chipsets? If everyone wants to buy, whether can they maintain it? Because so that's where with the GPU options, customers have got on AWS, whether it is NVIDIA, even the in-house built Graviton instances to provide best price to performance ratio. So coming to the next part, which is cost efficiency, right? So and scalability. So this approach addresses both of these questions. So with the customers not knowing how my application is going to scale, and whether it's going to be spiky, my usage is not going to be consistent. So in a traditional environment, you will always size the entire infrastructure for the highest traffic capacity, but you may not have the highest traffic capacity at that given moment, and the usage may vary. So here, you are able to build your solutions, applications to scale as your traffic changes. And so you're only going to, again, pay only for what you use, so which brings in high cost efficiency for customers who are building new applications there. So, so with the mission operations, with different modules that we saw here, what we're going to say is the value that we bring in is to help the customers is from an automation and orchestration standpoint. So building an event-driven architecture. So if you want to move at speed and scale, what we really want to do is how can we do an event-driven architecture? Say once the Earth observation image comes into an S3 bucket, how can we build programs, build tools to automate the entire data processing pipeline? So, so this is where different mechanisms again are available where AWS can help you build it, whether it is from a sequencing task or if a ground station contact has failed, how can you do an automated contacts rescheduling for the failed task? So, and at the same time, some of the business may demand prioritizing tasks, right? So how can we help prioritizing a contact data or processing a data that may involve saving human lives in a disaster scenario? So it is all about how can we support customers build these automation and orchestration tools. So what we see here is, I know there are a lot of logos and symbols here, so not to get worried about it. But when you see a full-fledged solution of a CMOC, of a mission operations on cloud, this is the reference architecture that you see. There are different AWS services being used for different part of the data lifecycle. So in short, customers can connect their application, the CMOC application, to AWS ground station or third-party ground stations, bring in data from the satellite into the environment, and have different modules connected to it for different processing, whether it is an SSA or whether it is data processing. So customers can choose and build these Lego modules as what their business needs. AWS is very focused on working with partners. So today, customers may not have the bandwidth or the entire capability to build their end-to-end solution. That's why we work with multiple partners. So what you see here is partners and third-party ISVs who have already built some of their modules on AWS Cloud, which can be readily used, integrated seamlessly with their existing platform. So this is these are some of the names that you can see as a solution. At the same time, we also built open source solutions. Customers who want to explore starting their business with open source. Again, there are options available for customers to choose their solution on what they want to run with. So this is, I would say, a kind of call to action. So you know whom you need to reach out to. So if you have a specific use case in mind, or if you can always come to us and we can build. You can come with a use case and you can get back with you can have a POC running in your environment. Or if you don't know where to start and you want to build a joint strategy, definitely we can always work with your team to understand your business use case and build a joint operation model as well. With that, I think this is the last slide. Yeah, so with that, I think thank you for your time, and I'm here to help. Yeah, thank you.
Thank you, Lakshmi. I mean, this was really very interesting. I think what Lakshmi you spoke about, and now let me bring on other panelists in. One of the things that I really picked up from Lakshmi's slides is that today we have approximately 10,000 satellites, and in next 2, 3, 4, 5 years there will be around 50,000 plus. So wow. So we do have a big a traffic problem in the space, and we also have the debris problem in the space. So let me bring in Tanveer first. So Tanveer is the CTO in Digantara. So Tanveer, also just introduce yourself. What you do. I think it's a startup, right? You started around 5-7 years back, right? And tell us that how you can make what you are doing to make clouds do satellite operations more efficient and reliable.
Okay, thanks a lot for the introduction. I'm Tanveer. I'm the co-founder and CTO of Digantara. As a company, Digantara is doing what radars did to aircrafts. Many of you must have flown here for this conference, and you are pretty confident sitting in your seat that the plane will land safely, right? But that was not the case always. A few decades back, collisions happened in space, in air, where aircrafts collided with each other. And just because sitting in the warm seat doesn't guarantee that you land safely. When accidents started happening in air, traffic management infrastructure was needed, wherein each aircraft is tracked and there is entire set of business functions that ensure that an aircraft safely takes off and safely touches down. Right now, we are at such an inflection point in space, where till now the traffic management in space didn't exist, and right now first set of solutions for creating traffic management infrastructure in space is coming up. Think of it of radars tracking aircrafts. Think of it as lane disciplines when you drive your cars. Think of it as signals. Think of it as traffic police. Whatever you think these systems on ground and air do for their crafts, Digantara does something very similar to spacecrafts. We build hardware, we build satellites, we build ground sensors, telescopes that primarily function to track satellites and space debris. And we utilize this data as an infrastructure to create maps of space, to create an operational picture of space where we exactly know where each and every object in space lies and where it will be in next coming days with very high accuracy. And that is essentially the first step towards creating a space traffic management infrastructure. Coming to the point on how we utilize the cloud. Traditional companies, let's say like ISRO and that league of entities, Their mission operations is quite different. Their on regulatory side, their frequency allocation, their object registration is from the same place. Their antennas are on the same place. Their mission control center physically is located on the same location, right? And for these kind of traditional missions to really take off, the ops infrastructure has to be placed, and only then the satellite is launched. But for companies like us and many of us here in the audience, it doesn't make sense for us to wait for our infrastructure to be in place to launch a space mission and start a business. And that's where cloud come into the picture, where I can use, I need not be restricted to antenna located in Delhi or Bangalore, but I can have 10 different antennas longitudinally separated across the globe and ensure that I have a data pass link every time the satellite revolves around the Earth. So that is really where cloud kicks in, wherein I can access any ground station in the world and have it controlled right at my office in Bangalore. And there is also a regulatory angle where you have to register your object, and usually mission operation centers are where you have registered your object from. But with cloud, you can really have your ops team split across time zones, and you can, although it's registered in a particular country, you'll be able to operate your satellite even from a phone if you like, if you build an infrastructure using AWS log that Lakshmi just mentioned, right? So that is really what gives what value that cloud brings for mission operations. Yeah, I think that is a good way to start.
Thanks, Tanveer. And let me now turn to Rajeev. So Rajeev is Senior VP with NeXat. So Rajeev, if you could talk about what are NeXat's solutions for the constellation management, and yeah.
Okay, hi everyone. I'm Rajeev Nair, and I'm the Senior Vice President Asia Pacific with NeXat. I'm sure not many of you are familiar with the company. So we are a Belgian company, and primarily we are an online e-marketplace for satellite internet services. We are the only satellite internet e-marketplace. And secondly, we have a cloud-based OSS/BSS platform which caters specifically for satellite service providers. So just for, I think, for you to sort of understand how we came into existence, we started back in 2011. And when we started, we actually started off as a satellite service reseller. So we were buying from a teleport or a service provider and reselling that in the market. Now, with that approach, we basically found two issues that we faced. One, we could only sell services that we were buying or what the hub of the seller could create. So, for example, without getting too technical, if the teleport or the seller could only sell dedicated service or container services, we could not sell voucher-based services, just for an example. So we were limited by the technology of the hub in terms of delivering services to our customers. Secondly, back in those days, there was no visibility or control available at our end or anywhere down the value chain as well. So from there, what we did was we started working on our own cloud-based POP. Now in that POP, what we used to do was typically three things. One, we did our own traffic shaping and routing. We did deep packet inspection, and of course, we enable a customer management tool to actually have the visibility of the network. Now, by doing this, we basically overcame all the limitations. We could, in that case, buy from anybody, create any kind of service independently, and sell it to the market while having visibility and control of the services. And at the same time, we could also extend that control and visibility down the value chain, right? Now, after these 13 years, we see the similar problem coming back into the market. Now, for those service providers who are working with the LEO constellation, say, if I can name Starlink, for example. Now, when you buy a service from Starlink, we as NeXat, we are in the process of onboarding as an authorized reseller. Now, when you buy services from someone like Starlink, you are limited by the fact that you can only resell those quota-based services that you buy from them. And then just add your, there's also restriction in what you can mark up as a price, but you're just reselling the same service. Now, by using or by bringing in NeXat into that solution, once again, you can overcome all those limitations which we actually sorted out 13 years back. So you can create your own kind of services, you can have visibility and management at your end as well as down the value chain. So that's the cloud-based OSS-BSS platform. The second thing is the e-marketplace, which of course I think I can touch upon later as we go along, but that's what we are.
Thank you, Rajeev. So Lakshmi, coming on to you, I mean, one is obviously, yeah, as you also mentioned, there have been traditional networks, right? And then people, customers have started to use cloud, as the network density has increased and all that. And obviously everybody can't scale up. But one part is obviously the customer confidence part. Has it increased as far as the cloud part is concerned? And second is obviously on the challenging side, especially, I mean, there are challenges related to cyber and all that. How are you handling, those challenges and kind of giving confidence to your customers that, okay, this is the way to go?
Yeah, thanks for the question, Pankaj. So I think getting confidence from customers is really about talking about case studies, right? So if I can talk about successful case studies of different customers, how they're using cloud, that's how we start building customer confidence. So traditionally, the space industry has been very conservative. I would say in terms of whether it is from a compute standpoint and storage standpoint, there is a lot of frugality in there, trying to do more with less. So that's definitely been the approach. But what we observe as a trend is a lot of these commercial companies, like some of the customers in SIA, Aerospace, Digantara, and Black Sky, Maxar, Capella Space, all of them are reimagining their space architectures. And a lot of these companies are currently operating tens and hundreds of satellites. OneWeb, again, which is one of the bigger constellation operators. So, so these commercial companies are really driving the change towards, because what they see is they see a great improvement in their efficiency. One such example is Leo Labs. So Leo Labs is one of the SSA providers globally, right? So what they have experienced as from using cloud as a platform is they were able to reduce their compute time by 99.9%, which means that they're able to deliver those timely information to the satellite operators, which can then help the satellite operators to take these important decisions from a maneuvering standpoint or from a collision avoidance standpoint. So secondly, all these commercial satellite operators, they did not launch a constellation straight away to 20s and 50s, right? The constellation scales all the way right from 0 to 1 to 10. So which means that if they need to deploy their traditional infrastructure, they would basically say that, okay, my constellation is going to be 650 or 800 satellites, so let me design the hardware for that. And so from a capital intensive standpoint, it is a significant cost of operation. So, but their core business is not maintaining the infrastructure, but their core business is delivering satellite internet using their satellites. So with cloud, they are able to scale all the way from 1 satellite to 600 satellites or 800 satellites without needing to worry about the application scaling. From a security standpoint, say they decide the operation of their region, whichever location that they want to operate their services with, and they're able to have encryption at rest, encryption in transit, based on whatever their business compliance or regulatory compliance requires. Thirdly, is with the end-to-end solutions here, customers are able to build the event-driven architectures and breaking those applications into multiple pieces. And instead of having just one large application, they are able to build it, separate out the logic into different components. So, like for example, Digantara has built one of their flight dynamics modules, which again, the benefit is that potentially customers, like what we saw, the entire reference architecture is like a Lego block. So a different satellite operator could use the flight dynamic module from Digantara and have their own command and control systems. So it provides extreme flexibility for customers to build their end-to-end solution on cloud rather than trying to build everything on-prem.
Fantastic. I have one more question, but anybody from audience, if you have any questions, then we can take on. Yes, young man. Yeah.
Thank you, sir, for allowing me to ask the question. Thanks to the organizing committee to allow me to attend here. And I'm Venkatraman Patnaik. I'm in grade 7, and I do research in avionics and telemetry. So this was a very interesting session for me. Cloud technology and management for avionics. Coming to the question for satellites, Tanveer sir explained that you can have enough infrastructure, the advantages of cloud technology to even operate it to operate it remotely from a phone or from a laptop or somewhere. And my question was that by using such cloud technologies, how can we create a cloud network of satellites? And in a network, we can synchronize those satellites to follow one orbit, or to maybe all focus on to one point. Maybe something that has something that maybe we can instruct satellites to focus over here. And how can we do that and create a basic network of satellites to basically replicate one another? Yeah, that was the question.
Okay. So I think, firstly, thanks for the good question and brilliant capability to grasp whatever we all said. I think that's not something very easy to do. So kudos for that. Coming to a place on your questions, satellites by nature are distributed, right? So that's the fundamental nature of satellites, that's the fundamental nature of orbital mechanics. Satellites don't like to stay in one place. They like to move at hypervelocity speeds. So I think converging satellites very close to each other is firstly not possible, and even I think we should not try to do that. If any satellite comes close to my satellites, I cannot sleep very easily. Right? I mean, anyone who's thinking of launching a satellite here would know that it would, I mean, even the cheapest satellite would cost easy $1 million or more to get it to orbit. And you would want other satellites and space debris to stay as away as possible from your object, right? So when it comes to creating resiliency, it's about a place where right now almost everyone has demonstrated that they can build satellites very well, operate satellites very well, and I think we are somewhere as a space industry in journey where everyone is trying to figure out scale. Right, SpaceX has done it very well. I think everyone, apart from SpaceX, rest of us are trying to figure out the scale. So during this scale, the ops infrastructure becomes very important, because when you're designing something, let's say a CFD problem, a FEM problem, an orbital mechanics problem, you don't mind waiting for a week or so, right? It's a design phase. But when you're ops, when you're running something, it has to happen instantly. And all of these blocks, especially the flight dynamics block that we are building, flight dynamics by nature is not fast, right? If your problems are linear, my problems are power of 3, power of 5, something of those sorts. So compute becomes one interesting thing to have, and another one is to have the ability to work with different ground station providers. Each ground station providers have different unique strengths and weaknesses, and for resiliency, you have to work with 3 or more ground station providers. And also, when it comes to the mission ops platform as a own, when we were figuring out our own mission ops platform, we figured out that everyone, I mean, not even a single mission ops platform has everything that a mission operation suits needs. FDS didn't exist in almost any of them. So that's where, and FDS right now is pretty important because you want to keep your satellite safe. So I think it's a combination of activities that has to scale parallelly for us to have these satellites operate in a sustainable way.
I'll add on to that. So I think one of your questions was how we can bring the satellites together. So conceptually, let me answer that from a perspective of a service provider end. Okay, now when a company is providing services on satellites, they'll work with different satellites, maybe on GEO, MEO, LEO. There'll be different bands, C-band, K-band, whatever, the different bands and different services. What a company like NeXat can do is give that company a single window visibility to the entire network. So that brings it together. That's one aspect of it. However, the other angle which I probably I like to share and it's interesting is you probably heard of sites like booking.com, right? So when you want to book a hotel room anywhere in the world, you go on that site, you just put the destination, you put what parameters you want, it'll show you everything, and then you can choose based on what you need, right? So same way, what NeXat has done is we've created an e-marketplace for satellite internet. So literally what you can do is you can go on our platform, you can click on the map where you want the internet. It'll show you what different bands, you can choose the band, you can choose the technology, you can choose a satellite, everything, and then it'll show you what service, what hardware, everything, and you can actually buy a service without talking to anyone in less than a minute. So that's another way how, as a company, we have brought in those satellites together in one space, making it more easy for people to access. So maybe that might not answer the entire question, but from a service delivery perspective, I think that's relevant.
So I'll try to break your question into 2 parts. So the first question that you asked was, how can you command the satellite to take pictures at certain locations, right? So there's something called, as you mentioned about telemetry, there's something called telecommanding. So you send instructions to the satellite to take pictures as and when you want. And that's what Tanveer mentioned about once you send the command and then you receive the data using ground station. The second part about you mentioning about convergence of satellites, I completely agree with Tanveer's point. If that happens, then we cannot sleep because we're just going to be only having debris all over the earth. But there are different ways, so there's different ways to solve a single problem. Please have a seat. There are companies who are building inter-satellite links. So as you know, Starlink has launched with inter-satellite links, and there are companies like Rivada who are building these connectivity, high-speed optical connectivity between satellites. So you can always, you don't need to converge from a physical standpoint, but you can converge it from a network standpoint and have your data delivered to any place across the globe, anywhere at any speed. So that's how I see a future. It's more, so every satellite in the space is going to become like a network device. So you're able to send a command, get downlink the image from anywhere across the globe. Yeah.
Any other questions?
As obviously a colleague of Lakshmi, I'm going to ask the other panelists.
Well, to start with, we are already in the cloud, but then again, we are also talking to AWS to do a lot of projects. I mean, we are integrating a lot of AI-based solutions into our platform, for which we are working with AWS. I mentioned that we operate our own POP, and in our POP, what we do is the traffic shaping of the traffic that flows in through our network. For that, we are trying to do some optimization, using AI models with AWS as well. So there are few things that we, of course, right now we are on a private cloud, which is our own. And then again, the first step would be for us to move to AWS as a public cloud. That's one wherein we can move. And then, yeah, for us to move faster, what we just need is the speed, the turnaround speed and the scalability, which is exactly what we are in discussion with you guys.
I think from startups perspective, right? No matter whether you create an ops platform, you create a software or a hardware and space industry, it takes much more time than any other industry. That's the nature of the business. That's the nature of the technology. Even a simple, an algorithm to know where the satellite is takes good amount of time to build. And I think the accelerator that AWS has, we have been a part of it. I think that helps really nice because our AWS costs go up and they stay there for quite a long time, and then it takes some time for them to come down because we first focus on functionality. I mean, any aerospace project, they focus on being functionally correct first and then focus on code optimization or algorithm optimization. So there is a, I think for startup, that could be a valley of death in some cases, right? If their cash flows are constraints, where they have to really focus on the optimization part where, in our case, because we had those credits, we could really use them and not worry about optimization on day one, perhaps on few months down the lane we do it. So I think that is a good, like a platform to remove a barrier of entry, I would say. I think that's one thing. And second thing, what I would say is, for us, practically, we have good amount of customers in the government sector. We have good amount of customers in the commercial sector. And government sector, no matter what you do, they're going to remain traditional, right? And we have to make it a point to ensure that our solutions, let's say if we are building it on AWS, which we do, has to be modular, has to be containerized, has to have Docker images and things like that. And we should ensure our tech stack is built in such a way that it can easily be deployed in a private cloud as well, right? Where governments don't like dependencies on something when you get node locked to AWS. So we really make it a point that we build what our customer wants, and I think every company in the room would relate to this, that their customers don't like if the infrastructure is locked to a certain ecosystem. They want to have options, which is not necessarily the case in commercial, but in many cases the first set of contracts comes from government sector. So perhaps easing some problems where I'm not sure how this fits in with your business case. Perhaps help companies to be AWS independent, but that's, I think, a quite tricky thing to ask. I'll leave you with that.
Yeah, that's definitely an interesting response. So definitely, maybe I could answer on few aspects here. So one is to answer Tanveer's question as well. So definitely building containerized applications and going away from a monolithic is something that I would say customers day in and day out has built, not just only in AWS cloud, but also that's how the application development has evolved right now. Coming to the private deployments, definitely we understand customers' requirements. So there are customers sometimes who require low latency as a solution, as a need. Some customers may say, okay, I need sovereignty. I don't want my data to be going outside the country. So depending on what the use case is, AWS does have solutions to address certain of these asks from the customer. So sovereignty is one such use case where it's been asked mostly by the government and defense agencies. So if you take AWS solutions for that, in the US, they have set up a separate deployment for Gov Cloud, which is primarily used by the government and defense agencies. There was a recent collaboration with Singapore, so where a dedicated private local zone has been set up for, in collaboration with the Singapore government agencies, primarily to be used by the government departments. So what we always continue to do is to listen to our customers. What is required, and basis that we work backwards to help achieve customers' business outcome. When a customer says, okay, low latency is my key ask, I would like to have, I want to have the flexibility of cloud, but at the same time, I want to have it on premises because my application is low latency. So one such customer is Inmarsat. So in there, what we do is we deploy the AWS infrastructure, we call it as Outpost, into the customer's environment, into a customer physical location. In there, the concept of cloud operations still remains the same because AWS manages the entire infrastructure and customers just simply use it just like how they will use any AWS region and use Outpost as a service. So depending on what the needs, what the business needs, what is driving the business needs, whether it is regulatory compliance or whether it is security compliance or whether it is customer compliance. So depending on what is needed, we always try to work backwards. If the solution is not available today within the AWS suite of portfolio, so what we do as the field team of AWS, we provide these inputs to the product and the service team across of the AWS. So which basically creates the demand signal. So then those demand signals are used as an input for the product and the service team to see, okay, this is what the customer is looking for. So how do we modify our product to meet these customer demands? So it's a continuous process, which is a cycle.
Hey, thank you, Lakshmi, and thank you all the panelists. I think we are almost coming to the close of this panel discussion. I think the summary is the traditional networks, can no longer be served, by traditional methods. Cloud is the way to go, and obviously, we have, AWS here, and then we have, other usage of the clouds also sitting, on this panel discussion. So I think all I say is, the satellite as an industry, I think is bound to grow. That's what, we are looking for in India. And there are obviously a couple of, policy, statements we still need to push, but hopefully in coming years, we will see, more of this, satellite industry, growing in the country. Thank you so much. Thank you for all the panelists, and thank you to all the audience. Thank you very much.
Thank you so much, sir. And thank you to all the panelists for providing such insights during the discussion. Now we'll proceed with the felicitation ceremony, for which I would like to call Mr. Pankaj Sharma to please come forward to felicitate our panelists. Mr. Tanveer Ahmed. Sorry. Mr. Rajeev Nair. And now I would like to invite Mr. Rajeev Gambhir, Deputy Director General SIA-INDIA, to felicitate Mr. Pankaj Sharma and Mr. Lakshminarasimhan. Thank you so much. I request you all to please come forward to take a group photograph.
Thanks, Rajeev. Thank you so much. Thanks.